Okay, this is number 5 from the Larsen 8.9 worksheet. And again, we're trying to get a power series. It says find a power series for the function centered at c. So in this case, my c is going to be 5. And it's going to be 1 over 2 minus x. So remember, if it's going to be centered at 5, we're going to want to have x minus 5 in here somewhere. So I've got a negative x, so in order to get a x minus 5, I know I'm going to have a negative sign, so when I take that out, I'll factor out a negative. So if I put a positive 5 here, and I factor out this negative sign, I'm going to have negative x minus 5. But I just can't add a positive 5. I have to add a negative 5 to make sure I'm just adding 0 to the denominator. Remember, we want to get this in the form a over 1 minus r. A is going to be my first term, and r will be my common ratio. So once we do this, we have our x minus 5, but we need to have a 1 here, not a negative 3, so I divide everything by negative 3. I have negative 1/3. Negative 3 over negative 3 is 1. Minus, and then x minus 5 divided by negative 3 is just, and I can put the negative over here, negative x minus 5 over 3. Now you can see where your r is. Okay? So now this matches this form. This is my a. There's the 1 minus r. Now we also want to find the interval convergence, so the absolute value of r, remember these geometric series will converge when the absolute value of r is less than 1, or r is between negative 1 and positive 1. So that's my x minus 5. If I take the absolute value, the negative sign goes away, of course. Don't have to worry about that. And then I can multiply all 3 sides by 3, all 3 parts. This makes this negative 3. This makes this x minus 5. That makes this 3. Then I can add 5 to both sides. So that's going to be 8, and that's going to be 2. And there we have our interval convergence. X will be between 2 and 8. Now once we have identified the a and the r, we know that this geometric series, the sum will be indicated by the summation. This will give us all of our terms if we go from n equals 0 to infinity. So we have our a, negative 1/3. We have our r, and it's going to be a times r to the n. There's my r to the n. So we just kind of substitute this data from this form into the summation. Then I can raise, I can put the negative down with the 3, and you'll see why we're going to do this in just a second. And then I can put this negative down with this 3. There's lots of ways to do these things, but this is to the n's power, so we got to watch out. So we have x minus 5 to the n all over negative 3 to the n. The reason why we did that is because we have a negative 3 and we have a negative 3 to the n. So we can combine these and make this negative 3 to the n plus 1, because I've got 1 negative 3 and n negative 3. So if I multiply that out, I just add the exponents. So that's going to be n plus 1, negative 3 to n plus 1. And this is my interval convergence, and this form should do it. So take a look at that, think about that. Try to get an idea on why we came up with this situation. Sometimes you've got to fool around with them. That's kind of why I do these in pencil, because if I come up with something a little bit different, I can adjust it. So you just have to kind of fool around with them and make them work. Okay?